Hi, Gigi. Okay, we'll get started. For this week, go ahead and watch the first 5 videos and think while it's in section 2 on limits, and really just watch them. Like, make sure your eyes are on the screen, listening to what he's saying, look at the visuals, and then watch this video. And this video will help you, like, what does the work look like? Now, what would be helpful to you is on maybe the back of this paper or another paper, draw a diagram, just a quick diagram of something, or a couple of words or a sentence to recap each video. So for example, put 2.1.1 video, or maybe the name of it, and then draw yourself a little reminder of what that is. Just in case then you want to review instead of watching the video, you have this thing that might make you remember what it is. All right, when you're evaluating the limit, I'm going to show you the work that you need to do. You also are going to need to be familiar with limit laws, and I'll explain what that means in a bit. But sometimes they get professors will refer to the limit laws, and being aware of them is useful. All right, so this is the work that I'm going to want to see. So when it says evaluate, remember that means do the math. So for this one, since it's just this linear function, I'm going to want to see this on your paper. So the limit as x approaches 2, we're going to put 2, subtract 3 in there, and that's going to, so the height, remember, this is the height. The height is equal to -1. And so then you rewrite this with the original function. And I know what you're thinking. Well, crud, I could just in my head say, yep, I know that's what you're thinking, but this is the work I'm going to want to see. Oops, except for you would put as the limit approaches. Now, graphically, let me show you what that means. So this is a y equals 1x minus 3. So we go up 1 over 1, up 1 over 1. So this slope looks like this. Oh, look at that. As you approach 2, right? As we approach 2, both sides of 2 right there, the x is 2, look at the height is down there at -1. So that's what it's talking about graphically. So that's what you're going to be talking about. Now, when you look at the limit laws, see how there's a subtract and an add? Another way that you could write this as the limit as x approaches 4, x squared minus the limit as x approaches 4, 4x, add the limit as x approaches 4, 4. They just want you to realize with limit laws that you can take, so this is how it's phrased. Let's see. For addition, subtraction, the sum of the limits, so that would be this right here, the sum of those 3 limits is equivalent to the limit of those sums. So the sum of the limits of those 3 polynomials is equal to the limit of the sums. So it sounds a little bit confusing. They mean the exact same thing. So again, you would write the limit. You don't have to separate them. I'm not going to make you do that. I just want you to be aware of the limit laws. So you would write parentheses 4 squared minus 4. Well, 4 squared is 16 minus 4 times 4. So those two zero out. So the height right there. So if you're doing this quadratic equation, as x approaches 4, you would be at a height of 4. So that would be that point 4, 4. All right? And then you would rewrite it as the original function. And all of this extra writing is just mostly for the purpose of you getting used to the notation. Now, notice there's a negative sign in front. Typically, what we're going to want to see is you move that. You can even rewrite it as -1 times the limit of that function. And then when you substitute in extra, so 2 times 4 is 8. 8 plus 5 is 13. So, and then -1 times the square root of 13 would look like that. I mean, you'd show the work. You would do that step next, but your final answer is then going to look like this. All right. Okay, so now when you've got rational, if you just plug, sometimes when you plug 0 in, you're going to get a function that doesn't exist. But even when you don't, before you even rewrite this, in the numerator, this says x plus 2. Well, in the denominator, this is a factorable polynomial. Those cancel, leaving 1. So now you would say, all right, the limit as x approaches 0, 1 over x plus 3. And then the answer is going to be 1/3. You would show this step first and then rewrite it. And then when you rewrite it, it's okay to go ahead and put the simplified version. Okay. And then for the trig limits, so remember the sine function, for one complete cycle, the sine function looks like this. All right, here's 2 pi or 360 degrees. Here's 0 pi or 0 degrees. And then we come this way, and this is -2 pi, etc. Okay, so they're wanting to know at -2 pi thirds, so that would be right about here. Well, on the unit circle, remember when you go negative, you go that direction. So this is pi thirds in the positive direction. This is 2 pi thirds. So in the negative direction, this would be -pi thirds. This would be -2 pi thirds. And remember on the unit circle, at -2 pi thirds, this would be, the x value would be -1/2. The y value would be -√3/2. And so how you'd show the work on that is as the x approaches -2 pi thirds, sine of -2 pi thirds. Now you might need to have the unit circle handy, and if you need a blank one, let me know and I can get not a blank one, a filled in one that you can look at. Well, we can see using the unit circle that that's going to be the height. If you just type that into your calculator, you're going to get a decimal value. We want the exact value. And then you just put it back in to its original form. And put the answer. All right, 10 minutes. Okay, I think I'm going to, no, I'm going to keep going. Dang it. All right. So these special rational absolute value, when you graph them, the parent graph would look like this. Let's see, f of x, either absolute value of x over x or x over the absolute value of x. And that parent graph, this is a height of 1, this is a height of -1. That's what the parent graph looks like, right? So, and 1 mean that's the slope. And it just works. If you were to do a table of values and you had this function right here, and we did this, whoops, -2, -1, 0, 1, 2, and you plugged -2 in there, well, the absolute value of -2 is 2, whoops, and over -2, sorry, 2 over -2 is -1, which is what I wanted. And then when you put -1 in there, you're going to get 1 over -1, which is -1. When you put 0 in there, well, 0 divided 0 is undefined. So that's where an asymptote is going to be. And then 1 over 1, absolute value of 1 is 1. 1 divided 1 is 1. Absolute value of 2 is 2. 2 divided 2 is 1. And so look at this height. And then -1, -2. So that's the parent graph. When you've got this, the first thing I'm going to want you to do is factor out a 5. This 5 right there acts as a slope. So now this graph is going to be up here and down here at 5 and -5. So we're going to have all right. So when you approach, oh, the other thing, remember, now this has been shifted. The opposite of -3 is 3. So this entire thing right here, let me see if I can just do it this way. We're going to shift over to 3 that way. We're going to shift over to 3 that way. And the asymptote now, whoops, at 3, there will be an asymptote. So that's an, oh, I should have put that there. That's an open dot because there's an asymptote running through here and an open dot. And now the graph is going to look that way. Now, when you ask about the limit, you're going to write these 3 letters. It says does not exist, because for a limit to exist, that's why you look at the limit laws, from the left and the right side, the height needs to be approaching the exact same height. But look at here. From the right, we're at a height of +5. From the left, we're at a height of -5. Those two heights are not the same. So the limit does not exist. And that's the work that I would want to see. So your final answer, the limit as x approaches 3. And here's a tip. For all of these that are not one-sided, meaning you're looking at them from both sides and how you know if it's one side or not. If they only wanted you to look at the right side, they'd put a plus right there. If they only wanted you to look at the left side, there'd be a minus sign right there. All right, so that's that type of limit. When it looks like this, you're actually going to pull out a negative sign, and that's going to say, I'm sorry, we're going to do this. So that's how you do one like that. But then you can pull out this. The absolute value of -1 is 1. So then you're going to have just 2 times the absolute value of x minus 1 over -1 times x minus 1. So now what you're going to have is you're going to go up to 2 and down to -2. The opposite of -1 is +1, so you're going to go over here to 1, a dot there and a dot there. But now 2 divided -1 is -2. So now we're flipping the graph. Instead of the graph looking like this, the graph is going to go that way with the asymptote being right there. All right. And then this says, hey, we're looking at what is the height coming from the right. Well, the height coming from the right, we're down there at -2. So if there's not a plus or minus sign on these types of problems, the answer is does not exist because the heights aren't the same. But if they only want you to look at where the height is headed coming from the x values from the right, we're down here at a height of -2. And then lastly, we've got a piecewise. So for this function, for all the values greater than or equal to -1, we're at a height of +3. So that's this graph right here. And then for this one, for all the values less than -1, we've got this thing going on. So this is a y equals -2x plus 3. So we're going to go up here, 3, and then the slope is down -2 over 1. So down 2 over 1, up 2, back 1. I'm going to put a hollow dot there. And that graph is going to look like that. Ooh, except for, hold on just a second. I'm sorry, I'm going to keep going. And the part we don't care about, because all we care about are for the values less than -1. So we actually can take a pencil or an eraser. And now what you see is this piecewise. So one has a hollow dot and one has a solid. And it looks like that. Now, it's asking you, as those two things, as you're looking from this direction and from this direction, are those two things the same height? They are not. So you would say the limit as x approaches -1, see how there's two functions? Well, this whole function makes up, both of those pieces make up that function. So you would say f of x and then just does not exist. Now, if they were coming from the right, well, from the right of 0, and this is the left of 0, so this is the only part of the graph that we care about. So you would say the limit as x approaches 0 from the right we have negative x. Well, the opposite, when you plug 0 into there, the opposite of 0 is still 0. All right, that's it. This was a 20-minute video, but that gives you an idea of how to do the problems.